Hi folks, we're going to take a look at number 2 from Unit 5, Lesson 5. So this is very similar to a Ferris wheel problem we've already solved. So here they're telling us that the diameter is 20. They give us information about the period, and they tell us that a person hops on at ground level. Okay, so while they're not being specific about that, if they're getting on at ground level, I think we can be pretty certain that this Ferris wheel is not going below ground. So we know that we've got our Ferris wheel. Okay, not the nicest of circles, but it'll work. Okay, and here it has a diameter of 20 meters, which means that our maximum height is 20, and then our minimum height is going to be 0. And then from here, we can determine our A and C values. So A is going to be, well, this will be pretty easy. It'll just be 20 minus 0 divided by 2, in other words, 10. And C, very similarly, 20 plus 0 divided by 2 also gives us 10. All right, and they tell us that one turn takes 2 minutes. So that means our period is equal to 2, which means that our K value is 2 pi over 2, which is equal to pi. All right, and the last thing that we want to look at is what our parent function should be and if we need a phase shift. Well, it tells us that passenger gets on at ground level. Okay, so that'll be the minimum value. So we'll use a parent of y equals negative cos x, and we won't need a phase shift. All right, so using all this information, we could come up with our model. So here y will just be equal to negative 10 cosine of pi x, then plus 10, and here y is the height in meters, and then x will just be the time in minutes. All right, so this is, we've done quite a few questions like this, except now there's an added part to this question. They want us to determine when the camera should be working in order to take the pictures every time the cart is 16 meters above the ground. So in other words, we want to determine all those times at which the cart is 16 meters above the ground, and those are the times that the cameras are going to be set to flash. Okay, now presumably there's a camera on either side. All right, so it's going to be taking pictures on either side as you're going up and then as you're coming back down. So it comes down to solving this equation. Okay, and we recognize this as being a linear trigonometric equation. So we're going to solve this in the exact same way as we solved number 1. Okay, so the first thing is to isolate cos of pi x. Okay, so here we'll bring the 10 to the other side, so 16 minus 10, and then divide by negative 10. So we have here that cos pi x is equal to, so 6 over negative 10 is negative 3 over 5. All right, and from this point here, we're going to solve it exactly the same way. Number 1 is we're going to start by using the inverse cosine function to find one of our solutions. So we know that pi x is going to be cos inverse of negative 3 over 5, okay, which is equal to, and let's get our calculator here. So we have cos inverse of negative 3 over 5 is 2.21. Okay, but of course we also know that pi x might be equal to, now in this case here we have to make sure that we use the correct related angle identity, and of course since we're dealing with cosine, it's going to be 2 pi minus this angle here, which is going to give us another possible solution. So 2 pi minus 2.21. So here we've got 2 pi, which is 6.28 more or less, minus 2.21, and so that's 4.07. All right, so the next step is to solve for x and if necessary, which in this case here it is. So we're just going to divide both sides by pi. So I'll do the second one first since I already have it on the calculator, divided by pi. Okay, so that's that'll be about 1.3. So x equals 1.3. And then here we've got 2.21 divided by pi. Okay, and that gives us, looks like 0.7. All right. Now, the other thing we need to know is that in order to generate other answers, we just need to add the period. In this case here, we already know that the period is equal to 2. So to generate all our answers, we're just going to take these, which are both valid answers because they are greater than 0. Here, t is equal to time. And now we're just going to add the period, which is 2. So here, the times are going to be, well, 0.7 minutes. Okay, and then the next one will be 1.3 minutes. All right, and now we can just add the period 2. So 2.7 minutes. Okay, we keep going until we reach a 3-turn ride. So let's figure out what a 3-turn ride would be. Well, 2 minutes each turn, 3-turn ride, so 6 minutes. Okay, so we'll just keep adding 2 to both of them until we reach 6 minutes. So 1.3 plus 2, so 3.3 minutes. Then 2.7 plus 2 is 4.7 minutes. And then 3.3 plus 2 is 5.3 minutes. And that's as far as we're going to go. Because if we add 2 to either of these, we're going to be beyond the 6-minute time for this ride. Okay, so to recap, step number 1 is given the scenario, come up with a model. At that point there, they're giving a specific y value for which we need to solve for x, and that created a linear trigonometric equation. And from there, we solve that by first, step 1, isolate the trig ratio. Step 2, determine your 2 answers based on the inverse trig function and the related angle identity. Step 3, solve for x. And step 4, determine all the possible solutions by adding or subtracting the period of the trig expression, which in this case here was 2. Okay, that's it for this one.